So for standard 5.2, I did a problem from the book, problem question number 5.49. On the problem, we are asked that find the Fourier coefficients an and bn for the function shown in figure 2a, which is this function over here, and make a plot similar to figure 2.23, comparing the function itself with the first couple of terms in the Fourier series and another for the first 6 or so terms. Okay, so from the function, the first thing that we first notice is that we can figure out the period. We know that the period, you can calculate the period by just taking where the maximum is, so from here to there, so we know that's 2, so I can figure out the period is 2. And using the equation given us in the book to find f of t, we know f of t is equal to this whole equation, where this could be taken as an integral from n equals 1 to infinity. What we also realize that this function is very symmetric, and it's also even. As a result, this term sine will go to 0, because sine is an odd function. So that means bn is going to be 0. So for this graph over here, we're just going to be dealing with an and a naught. Alright, so to figure out a0, we know that the equation in the book gives us that a0 is just equal to this function where f of t max. And we're told that f of t max is equal to 1. Take the integral of that, you get f naught is equal to just 1/2. To calculate a1, we are given this equation from the book, where f of t is just the equation of the line sloping downwards. So since this is 1 and it's sloping downwards to 1, we know that the slope is equal to 1. So as a result, f of t is equal to 1 minus t. And what we did is, since we know that this is just repeating itself, I just took the integral from here to there, from here to here, and multiplied it by 2. So this is where I just multiplied this thing by 2 and took it from 0 to 1. And what I did, I just substituted because I know t is 2. So this comes 1, that becomes -1, but since I'm taking from 0 and multiplied by 2, I get this equation. Using Mathematica, we figure out that an is equal to this function, and we know that w is the angular velocity, and that's equal to 2 pi divided by the period. And since we know the period, that means angular velocity is equal to pi. Plugging that back into an, we see that an is equal to this whole function. What you should notice is that cosine pi and t, when this value, when n is even, you just get cosine equals 1, and then that means these two cancel out, so an is going to equal 0 when n is even. However, when n is odd, you get this whole term equals -1, and then that then it gives you a couple of values for n. So we already know a0, which is 1/2. To find a1, we just plug in 1 and then solve, and that's what I got. Now, plugging this into Mathematica to make the plot. So as you can see, those are my functions. So I plug it into Mathematica to make my plot. Let me just make sure you can see it. And that's the plot that I get. Now, it's not as defined as it could be, but if I took more terms for a, it will become more defined.